Hello everyone, we are from Group 14 MS4101 Sustainability Aspect for Mechanical Engineering ITB. Today, we are going to give you a summary of a paper titled Integrating Life Cycle Assessment and Eco-Design Strategies for a Sustainable Production of Bio-Based Plastics by Venkateswaran Venkatachalam et al. But before we tell you more about this paper, it is important to know the definition of LCA and eco-design. LCA is an analysis technique to assess environmental impact associated with all the stages of the product's life, which is from raw material extraction through material processing, manufacture, distribution, and use. Meanwhile, the eco-design is a well-established approach in designing a product with the consideration and integration of the environmental impacts of the product of the system. Here, we'll be discussing about plastic base of product. Plastic has been our necessity for at least over 100 years. It's mostly made out of fossil resources like crude oil. Apart from it ruins the environment, fossil resources are depletable assets, which means our future generation will not be having any benefits from it. However, in the past few decades, researchers are now focusing on bio-based plastics. Bio-based plastics consist of biopolymer and additives. Bio-based plastics are humans' potential solution for fulfilling the needs of the plastic, while also keeping the earth sustained. In this paper, identifies the practical needs for integrating LCA and eco-design strategies into the production. The objective of the study is bio-based plastics for a computer mouse body made of polylactic acid or PLA. First of all, we need to know the description of the eco-design process stages as applied to the case study, which is a computer mouse. In order for this integration to work economically and environmentally, we have to analyze the benefits and the motivation of the study. The motivation factor not only arises from the manufacturing company, but also from external factors such as policy and markets. Here we are providing you some examples. The first one is increasing the marketability of the bioproduct plastic through product innovation, thus increasing its demands and reducing cost of raw material. Second is improving the product mechanical and environmental performance by reducing energy and material consumption. The third is clear communication to the customers and consumers with regards to the product mechanical and environmental performance.
Okay, before we determine the methodology, we should know that in eco-design process, it requires a multidisciplinary approach such as economical, technical, ergonomic, market, and environmental properties. These aspects are connected to each other, so we need to pay attention to each of these aspects in this eco-design process. Next. Okay, because in this process using a multidisciplinary approach, in determining the eco-design strategy, a team from different disciplines are also needed. Here are some of discipline needed for an eco-design team. First is material engineer. Material engineer are responsible for the design, developing, choosing, and testing the materials. The second is technician. The third is the process engineer. This process engineer will responsible for developing and implementing process strategies and optimizing the process in order to reduce the cost. The fourth is the project manager. The project manager will lead the eco-design team planning, executing, controlling the process that have been made by the process engineer. The fifth is the sustainability expert. This special will coordinate the sustainability aspects such as an environmental, economical, and social in order to balance the environmental responsibility and business efficiency. And then the last one is the human resource personnel that will manage the human resource in a eco-design team. Next. Then we go to the metallurgical stage. The first stage is determining the process of the product system. Properties referred here are mechanical and chemical properties. Then we need to consider the environmental aspect, cost, market presence, and the social aspect. Then the next stage is a life cycle assessment of the product system. This stage is consists of identification of the value chain. Then we interpret the result of the life cycle as impact assessment and the life cycle assessment itself. After we interpret it, we analyze the scenario and the sensitivity of the product, and we select the criteria for the polymers or additives. After the life cycle assessment stage, next stage is eco-design strategies. These strategies consist of the prioritization of the strategies and concept, environmental and social relevance, economical and technical feasibility, and time frame and management approval. The last stage is implementation and feedback. In this stage, we need to assess the product after the eco design and implement it at the pilot scale. After it, we do the meeting with the stakeholder and take the feedback from team and the stakeholders. From different stages previously described, it can be seen that identification and implementation of eco-design strategies is an iterative approach supported by LCA implementation. Next. Okay, the main goal of this LCA study is to analyze the environmental performance of the product made out of bio-based plastic and then identify opportunities to optimize this product. The result of this LCS study will be helpful to analyze the individual contribution of different processes towards the total environmental impacts. Next, the functional unit of the LCS production of 1 kilogram of bio-based plastic blend made primarily of biopolymer polylactic acid to be used to manufacture 25 pieces of computer mouse bodies, which include right mouse button, left mouse button, palm rest, and the base. Okay, next.
Okay, from the system boundaries, we set the boundaries from cradle to gate. The first one is raw material acquisition phase. The next one is production of the bio-based plastic blends. And the third one is the processing of the blends. This paper didn't include any phase at consumer and Westlife because of the limitation in the data, and for those two phases they got into eco-design strategy definition which are not included in this paper. For raw material acquisition phase, which are the material is polymer, additives, and other chemicals, will perform first manufacture, and then processing, and then the last one is transport. All of this stuff is brought from each site or original site to Germany for making blends with the main compound of biopolymers, polylactic acid or PLLA from sugarcane and polydilactic acid or PTLA from sugar beets. This process is included in the pre-processing bio-based plastic blends. While for the utilities that are considered, such as process steam, process water, compressed air, and output flows such as emission and waste.
Next is lifecycle inventory data sources and data quality requirements. First of all, let us know the system boundaries of the product system, the computing mouse. The first phase is for material acquisition. And to continue to the next phase, we transport the thing from the raw material acquisition to production. After the product is being produced, the product will be transported to the processing phase before finally distributed to the consumers. The first phase is raw material acquisition. In the raw material acquisition, uh, we will make polylactic acid, or PLLA, as been described before. The polylactic acid is made from the sugar cane, which imported from Thailand originally. Then the sugar cane is being weighed and shredded to break the fibrous stalks apart and burst the cells that contain the sweet juice. After that, the sugar cane is crushed through a series of rollers, separates the juice from the leftover fibrous materials. After from the phase of sugar milling, the lactic acid is being resulted. The lactic acid is 90% obtained from fermentation. And finally, the polyl-lactic acid is resulted. The polyl-lactic acid is an absorbable, semi-permanent, injectable implant that can be used to gradually restore volume and stimulate collagen formation. From PLLA, we can result to product, which is processing aids to help and aid the processing in the next phase in the production. And the second is nucleating agent, which has a surface charge that is opposite to the partial charge of the chemical moiety of polymer. This nucleating agent accelerates the rate of crystallization, which provides the improved dispersion of the nucleating agent. Nucleating agent improves dispersion in melt-processable polymer, so it begins the formation of crystal at higher temperature than melt-processable polymer itself. Here we can show the PLLA, or at first the lactic acid from the sugar milling, which is shown in the right picture. Okay, next. The second thing is poly-D-lactic acid, or PDLA. PDLA is imported originally from Spain. Different from PLLA, PDLA is made from sugar beet and processed through sugar refinery. In sugar refinery, the main objective is to refine a white sugar, and then there is a bypass product called molasses. Molasses is the main product to produce further for yeast and animal feed. Since we're using the waste product or the bypass product, the manufacturing cost of lactic acid will be reduced. The PDLA itself, on its addition, gives a strong strain hardening character so that it can be a plasticizer and giving a strong impact so that it can be impact modifiers. The second phase is production. From the production, we can see that the first phase is extrusion, continue to granulation, then crystallization, and the end is vacuum packaging. The production itself takes the material from Spain and Thailand, as discussed before, and production takes place in Germany. The extrusion itself is a process that used to create objects of a fixed die profile by pushing the material through it. Then second, the granulation is the process of forming grains or granules from a powdery or solid substance, producing a granular material. The third one, crystallization, is process by which a solid forms where the atoms or molecules are highly organized into a structure known as crystal. And then the last, vacuum packaging, is a method of packaging removing air from the package prior to sealing. The method involves manually or automatically placing items in a plastic film package, removing air from inside, and seal the package. And the next phase before we distribute to consumer is processing. In the processing itself, it takes 4 sub-phase. In the production, we can see that the making of extrusion, it's ram pushing the billet to make the wanted shape, and then granulation is the making of granules. Crystallization is turning the granule into a solid crystal, and then vacuum packaging as shown in the picture. Okay, in the processing, the first of all is pre-drying. Pre-drying is required for good molding. Then absorb or surface moisture. If we don't do pre-drying, will cause a pore and a poor joint line. Second is injection molding. Injection molding is a method to obtain molded products by injecting plastic materials molten by heat into a mold, and then cooling and solidifying them. And after all, it been transported to the assembly line and packaged to make the distribution to the consumers. All the system boundary is obtained from the source as shown below. The data source for production and processing phase is obtained from primary inventory data because the writer has cooperated with the industry. But for PLL and PDLA, it used regional specific secondary datasets for product because there is confidential issue with the industry related. And then for the transportation includes transoceanic, intracontinental, and local transportation, which their distance is calculated by an online tool called EcoTransit, which calculate distance based on realistic transportation scenarios. Next is impact assessment and interpretation. Here we can show the impact assessment results of 1 kg of bio-based plastic blend used in manufacture. It is recommended to display characterization of each midpoint impact, and the recommendation is given by LCIA. LCIA results were obtained from the method impacts in Gabi software. Here we can see value per functional unit is equal as priority scale that the GWP has the most priority scale over all impact category. And then we can see the graph for relative contribution of life cycle phases, cradle to grade, towards each impact category indicator. Acquisition has 95% impact in 8 out of 11 categories. This impact is mainly induced by PLLA transport and production, and also process steam and power consumption. In ozone depletion potential, raw material also contributes the most. That is 86%, and the cause of the impact is by impact modifiers that made from PDLA, the fossil-based acrylic additives.
Okay, now we are talking about scenario analysis. Scenario analysis is a method where binary condition, which is type of process and associated quantity of some of the key process parameters, are modified in the inventory in order to analyze the variation induced on LCIA result. Scenario analysis can be a powerful method to identify different potential strategies supporting the optimization of products and environmental performance. Okay, next. Okay, there are scenario analysis. The LCIA result highlighted that a significant amount of environmental impacts come from the transoceanic transportation of the polymer polylactic acid or PLLA, that is the transportation of polymer from Thailand, where it was originally manufactured, to Germany, where it will be used in the manufacture of bio-based plastic product. In the scenario analysis, the transoceanic cargo transportation of PLLA is kept as a base scenario, compared to a scenario of cargo transportation of PLLA from Spain and another scenario of truck transportation of PLLA from also Spain. Although there was no significant change in the most of the impact categories, can be seen on the side chart. Change in the most significant impact categories, that is acidification potential or AP, global warming potential or GWP, eutrophication potential or EP, and photochemical ozone creation potential or POCP. For the two scenarios is shown alongside the base. In this chart, we can look at least 21 or at least 20% reduction is observed in the total impact on when the PLLA is produced and transported by truck from Spain to Netherlands when compared to the base scenario. Okay, next.
Okay, identification of eco-design strategies. So now we have table 2, proposed eco-design strategies after analyzing different aspects of the bio-based computer mouse body. Looking for many aspects which are environmental impacts, economic, and technical feasibility are scored arbitrarily on a scale going from 1 to 5. From 1, the lowest feasibility, either like too much spent of money, limitation of the machine, or not too relevant with environment improvement. Differ from those aspects, time frame using short, medium, until long term. For example, sourcing polymers from Europe, it has scored 4 for environmental improvement, which means higher impact for environment improvement, and economic feasibility got scored 2. It means maybe too expensive, and the technical got score 5, great feasibility, and LT or long term, good implementation for sustainability. So we should make a clear LCA and communicate the LCIA results for material development. Improving the mechanical, ergonomic, recycling, and biodegradable properties of the product not only have a high environmental relevance, but also helpful to position bio-based plastic products as a sustainable option in the long term.
Okay, the conclusion of this article. The life cycle assessment of a bio-based computer mouse body was conducted on a cradle-to-gate basis. It was found out that the raw material acquisition phase constitutes the major share in all of the environmental impacts. Several strategies for eco-design of a bio-based product were identified in this article based on the life cycle impact assessment result, scenario analysis, and consideration of some alternative aspect of the product. Some of the methodological and practical requirements for implementing eco-design strategies at the level of bio-based plastic manufacturing were also shown and found in this article. Once implemented, the strategies should pave the way for a sustainable production of bio-based plastic.
Okay, next. Okay, well, that's our presentation. We will apologize if there is an error or mistakes. Thanks for the attention. Have a nice day.